One thing we've seen about photonics in the past couple of years is it's being adopted as a platform for more and more applications. I'm speaking of silicon photonics in particular. It has evolved from a platform for high speed, high throughput, high capacity interconnects for data centers into a platform for so much more, ranging from biosensors for next generation Apple Watches and other wearables to LiDAR on a chip that will provide vision for autonomous vehicles. So many new applications. And with those new applications come new demand. We are starting to see analysts looking at these new applications and projecting volumes that are going to be a problem. They're going to be a problem because right now, if you listen to the industry players for silicon photonics, Intel, for example, has achieved an annual rate of over 2 million transceivers for data centers every year. That's an incredible achievement. But then you see some of these other applications that are being forecast for 1,000 times more chips per year. LiDAR for cars, for example. There are a lot more cars than there are data centers out there. Wearable technology, quantum computing is another up-and-coming application that is going to need silicon photonics. We need to automate, and we need to take advantage of the high-speed capabilities that have come to market in the past few years. For example, here is an example. It's a serving suggestion of an application that will require very high-speed manufacturing. Here we have taken a platform, and that platform can be any diameter. This platform is big enough for 2 chips to be processed simultaneously. So you can have 2 process steps operating in parallel here. And so we're doing a double-sided alignment of an array device, a multi-channel array device. The technology that we're showing here is capable of performing simultaneous alignments of inputs, outputs across multiple degrees of freedom. So rather than lengthy loops, it just happens in typically less than a second to get the alignment. So you can see on the screen the alignment processes and the scanning processes, the characterization of the devices all happening very rapidly. And you can imagine a carousel like this with pick and place in one location and glue dispensing and inspection, metrology, all happening in parallel. That is the kind of throughput-oriented architecture that the photonics industry must adopt if we are going to keep pace with the demand that we see coming from these new applications.